Hello y'all, welcome back. Today we're doing 12.2 on arithmetic sequences. And first we're looking at the formula. So a sub n equals a sub 1 plus n minus 1 times d. And the d is the common difference. A sub 1 is your first term. A sub n is like the term you're looking at, the value of it, and n is that term. So let's look at this in an example. So find the 41st term in an arithmetic sequence of 2, 6, 10, 14, 18. So first I can find the difference by doing the second term minus the first term. So 6 minus 2 is 4. So d equals 4. And then I know the first term, a sub 1, equals 2. And I am trying to find the 41st term. So my n equals 41. But I don't know the amount of that 41st term. And that's what a sub n is. That's what we don't know. So let's plug in what we do know into the formula. So a sub 41 equals 2 plus 41 minus 1 times 4. 41 minus 1 is 40. 40 times 4 is 160. Plus 2 is 162. So the 41st term has the amount of 162. So if we kept going by adding 41 times, we would get the amount of 162. Okay, so next, the 8th term of an arithmetic sequence is 85. So that means a sub 8 equals 75. The 8th term is 75. And the 20th term is 39. So a sub 20 equals 39. I don't know the first term. I don't know the difference. So I'm going to take both of these information that we know and put it into that formula to create two equations. So a sub n, so we'll use 8, is 75 equals a sub 1 that we don't know plus n, which is 8, and then minus 1, and then times d, we don't know. And then same thing for a sub 20, so 39 equals a sub 1 plus 20 minus 1 times d. I'm going to simplify these equations a little bit, so this can be 75 equals a sub 1, 8 minus 1 is 7, and then 7 times d is 7d. And then same here, 39 equals a sub 1, 21 minus 1 is 19, times d is 19d. So now we have two equations, and we can do this like solving for our systems of equations. I'm going to use elimination because I have a1s of same coefficients. So I'm just going to subtract the second equation from the first one. So I'm going to subtract that. So 75 minus 39 is 36, and then a1 minus a1 cancel, and then 7d minus 19d is negative 12d. I'm going to solve for d by divide by negative 12, and I get d equals negative 3. So now I know what d is, and I have one of my terms. And I can just plug in this into one of those original equations that we solved for. So 75 equals a sub 1 plus 7 times negative 3. 7 times negative 3 is negative 12. And then we would add that to the other side. So 75 plus 12 is 96. So the first term, a sub 1, is 96. Okay, so now we are trying to give a recursive formula for the sequence. And to do that, we need to know the first term, which is 96. And we need to know the difference, and that is negative 3. So to find any term, which is a sub n, you take the first term before 96. So you write that as a sub n minus 1, and then you add the difference. So plus negative 3, which gives us a sub n minus 1 minus 3. Next, we are looking at what is the nth term in the sequence. And we can say we're going to use that formula that they gave us and plug in what we know. So we have a sub n equals a sub 1 plus n minus 1 times d. A sub 1 is 96. And then we have plus n minus 1 times negative 3, which is our difference. This becomes 96 minus 3n plus 3, or a sub n equals 99 minus 3n. Okay, next we are going to look at the sum of an arithmetic sequence. And we have a couple formulas for these, and you really want to look at what you're given in the problem to determine which one you're going to use. So in this first one, we are finding the sum, S sub n, of the first n terms of the sequence. A sub n equals 3n plus 5. So we are trying to find the first n terms. So let's just write down what we know. We can start plugging in values. So let's figure out what the first term is. So 3 times 1 plus 5. 3 plus 5 is 8. So our a sub 1 equals 8. And then a sub 2 would be 3 times 2 plus 5, which is 11. So here, 11 minus 8 is 3. So that's how we find our difference. And then n, we're trying to find the nth term, which is n. So we're going to plug this in. We have a sub 1, we have n, and we have d. So that means we're going to use this equation here. So we have s sub n equals n divided by 2. And then we have 2 times 8 plus n minus 1 times d, which is 3. And then we can start simplifying this. So n over 2, 16 plus 3n minus 3. We get n divided by 2 times 13 plus 3n equals s sub n. And then that is how you find the nth term. It's not an actual number because at the nth term, we weren't given a term. So whatever we plug in, we can plug in any value. Say we want to know the 8th term, the 20th term, the 110th term. You can plug that in and figure out what it is. So when it asks you the nth term, you're getting like a equation to solve for any term. Okay, so now the next one, we're actually finding the sum. So let's write down what we know. We know a sub 1 is 60. And we know the last term, a sub n, is 120. And then the difference is 4. D equals 4. So it looks like, again, we're going to use that same equation. So we have a sub n equals a sub 1 plus n minus 1 times d. We're using that first equation because we don't know what n is. And to find the sum, we need to know what n is. So let's plug in everything. 120 equals 60 plus n minus 1 times 4. This equals 60 equals 4 times n minus 1. We get 15 equals n minus 1. N equals 16. So now we know n equals 16. And we can go back and use this first equation and find that sum. So s sub n equals n, which is 16 that we just found, divided by 2. And then a sub 1 is 60. And then a sub n is 120. And then this equals s sub n equals 8 times 180. So S sub n equals 1,440. That's all for today. Let me know if you have any questions.